Welcome to a video presentation on the calculation of net present values and internal rates of return. Both are very important concepts in finance, and the math looks complicated but is actually quite simple. It's just based upon, at least net present value, on the calculation of the PV given a future FV. And I'm going to go ahead and show you using situation A just some basic math, and then I'm going to calculate using Excel and a phone app, and then finally I'm going to end with a little bit of discussion on rate of return. So let's take a look at situation A. Let me get my pen here, and if I take this pen, I can draw out what's happening. On this one here, this is your first cash flow. So what you're doing in essence is you're taking this first cash flow of $300 and you're discounting it back at 1 plus R to the first, and then you're going to keep adding it each one. Here's your second one, which is $400, and 1 plus R, and I got to put 2 here, and I'm going to continue to add each one of them. But one way I show a lot of times doing calculation time value money, especially present values, instead of dividing, I like to do a little trick referred to as multiplying by its reciprocal. Here's the reciprocal, and I can just keep doing this. So instead of dividing, I multiply it by a -2. Either way, you'll get the same answer on this. And if you take a look, since you're adding each of these cash flows up, you get the N of the net of these present values. Sometimes you'll see the this formula, which is summation, if you will. Now there are a few parts that we have to know, and here's the 3 parts here. We have to have an initial inflow, or sometimes referred to as an outflow, when I'm spending the money on this long-term asset that's going to generate future cash benefits. We have to know the future cash benefits, or at least a good guesstimation of what we think they are. And then there could be a terminal value, like a salvage value. So there's 3 things we have to know. And finally, there's the rate of return. Now, I'm going to not go a lot into detail of the rate of return. We could spend a lot of time. I'm just going to go ahead and throw a big number of 20 to 30%, and there's a reason why I'm using a larger number, and I'll explain that when I get over here to this example here. So let's go ahead and, just for the fun of it, let's calculate this one with Excel. Now I can do one of 3 things. I'm just going to hit formulas in finance, and I'm going to look it up under net present value. I could have typed equals NPV in parentheses and it pulled up, or I could have just went to recently used if I've recently used it and find it. Now I'm going to go ahead and start with the rate. There's the rate, 30%, and I'm going to click on the value number 1. Now if you notice a few things, one, I have in Excel not a place for value 0. That's an issue. I'll come back to that in a moment. It requires an Excel us to do an extra step. But also, if you take a look at here, this 230.77 is this calculation here, either dividing by 1 plus R to the 1 or multiplying by 1 plus R to the -1 will give you this, and it's going to just keep summing up. So every time I put another value here, here's value 2, it now took this number and added them together, hence the summation, or the N for net present value. So 3, and I can just keep doing this as long as I want, and it'll just keep doing these for us. And here's 5, and here's finally 6. And now I have my answer. My answer here is the net present value of these cash flows 1 through 6, discounted back at 30% and added up, is worth $1,141.30. Would you purchase something for $1,000 that's worth $1,141.30? Your answer probably will be yes, because it's worth $141 more than our initial purchase. Now I'm going to grab the fill handle here, a little trick in Excel, and pull it across. I can calculate the next one since it's already in. You can take a look at the cash. The number's a little different here. I set it up that way so that it would be a little higher. I put larger cash flows early on than later cash flows. You can see that the timing of cash flows can be important here. Now, if these 2 projects were mutually exclusive, that means I pick one or the other. I think most people would say, since they both cost $1,000 and this is worth $168.34 more than the 1,000, this is only worth $141 more than the 1,000, you'd probably pick B, situation B. If you could pick both of them, you'd pick them both, because both of them are greater than the initial outflow, which means they're returning greater than this 30%. Now I mentioned it a moment ago. I'm going to show you another calculation. I'm going to go to a website and an app called FN Calculator. Here's the app for your phone. And I've already typed everything in here. You see, and it allows me to put a zero cash flow. I'm going to pull down and I'm going to hit calculate. When I hit calculate, it's going to give me the 141.30 because it's already added these up and subtracted the cash flow zero $1,000 and gave me my 141.30. You can also see, since it's greater than $1,000 by 141.30, the internal rate of return is greater than 30%, actually 35.94%. Now let's play it again. Let's play with the rate on this one. I got different numbers, but I play with the rate. Now you can see the number is larger. When the rate's smaller, the PV will be, or the present value of these cash flows will be greater. I won't name any companies, but there's a lot of companies out there that like to give cash today for future cash benefits that you might be receiving in some type of structure or annuity. They would like to pay you as little as possible for those cash, and I would assume that they use a very large discount rate because of that. Finally, I want to calculate this internal rate of return here, which I already calculated. I want to calculate it again. Internal rate of return. So in this case, what if you were going to spend $1,000 and these are the cash benefits, and you don't know what the rate of return is? You could simply, and this is where, again, formulas, I can go finance or I can go recently used, and I've used it recently. Here it is. Excel will allow us to put the zero cash flow in for IRR, whereas it will not for NPV. So all I have to do is, you see here, I could guess. I don't need to guess. I have the values. I just pull right down, and it gives me my answer right here. And it tells me 38.84, and I can go home here and I can change the, if I'd like to. I'm going to leave it at 38.84. And you can see that that is greater than the 30% if that was what you were shooting for. That's a good return. Now, I had mentioned the rate earlier, and I said the importance of the rate. Well, I'm going to come over here and show you the cost. It's referred to as weighted average cost of capital. I have a video on that as well, a little more detailed. This one is going to be a really quick one. It's the cost in which you have to purchase, raise capital to purchase assets. Everybody knows that this is the balance sheet. It's a permanent equation. Here's all your debt or liability, and there's your equity, and you put them two together and you get assets. Well, how much it costs me to borrow and how much it costs me to sell stock is the rate at which it's my cost of capital, if you will. So I went ahead and put the formulas here. They probably look familiar. You've had a corporate finance class. Here's your R-star and IP, which is your treasury bills, and I added some default, liquidity, and maturity risk premiums to get my coupon payment of 8%. And then here's my capital asset pricing model here, which uses the risk-free rate, which is here in purple, and a few other calculations, beta and the risk of the market. Let's say I got 12%. One thing you have to remember is that all debt is written off, so I have to take it as an after-tax cost, but it's not here. And here's the weight, which means that if this was 100, there's $50 here and there's $50 here because it's 50-50. It could be 200 and 100 and 100. Doesn't make any difference. It's just the percentage here. So let's go ahead and calculate this. First of all, I'm going to calculate the cost. Now the cost of debt would be, we have to remember, is this, but I'm going to multiply it by 1 minus the tax rate, because in essence I'm not paying the taxes, I'm paying 65% instead of the full 100%. I'm going to close it, so I'm really only paying about 5%. I'm going to come up here and change my, so I get 5.2% one more time. And then over here it's really easy because it's still 12%. Now one more time is the weight. So if I take the weight, which is the 50%, and I multiply that by the 5.2, I get the new number, the weight, and I'm going to do the same thing here, 50% times the 12% cost, and I get the 6%. And if I come here and add them together, this plus this, I now have my cost of capital. That's still far less than the 30%, but you got to remember, we may not know these numbers. These are guesses a lot of times. So let me go to and do this one more time and show you a real one and show how high it could be and why you need some, I guess, some meat on the bone, if you will. I got a website here called That's Whack, and if I put in the ticker symbol, and we'll put in the ticker symbol for Disney, D-I-S, and I'm going to calculate weighted average cost of capital for Disney. And you can take a look. Here's according to what this website, now I calculate these myself, but I'm just going to use the website. You can see it's 12.5%, close to between 12.5 and 13% to the cost to run Disney. So you can see if that's 12.5%, you may want to have some wiggle room. And if you do get 30%, the difference between the 12 and the 30% is what you've added back to the company, and you increase the stockholders' value. So I hope this helped a little bit with capital budgeting.